Okay, today we're going to sort of combine a couple different units or sections of the chapter together because they sort of similar to what we did last time. We're going to look at sine graphs and sinusoidal functions and figure out where the midline is, what the amplitude is, what the period is, and domain and range like we did before. So we'll start with a graph. Okay, so we're going to look at a sine graph. So this rough sketch I did is not very good, but it'll work for us. So we have a sine graph starting at -4. So you can see the y-intercept's at -4. It's going to go up to 8, back down to -4, up to 8, back down to -4, and so on. So what you have to be able to do is figure out how can we get certain bits of information from this graph. So the first one we're going to look at is the midline. And just like it sounds, it's the line that would cut this thing in half. So if you go from -4 to 8, that would be 12 squares, so that means half of that would be 6, so we could go down 6 squares from the top or move up 6 squares from the bottom, whichever, so we get a midline at 2. So we can do it just sort of by common sense, or you can even kind of follow a little bit of math. The midline would just be the average between the two, so if you do 8 plus -4 divided by 2, that'll give you 2 for an answer. So either way, either use the formula, like add the 2, divide by 2, or just kind of use common sense and count squares and figure out where the middle is that way. So midline in this case is at 2, and that's good. So now let's do amplitude. And amplitude, same thing, you can use common sense. It's going to be the distance from the midline to the peak. In this case, so from 2 up to 8 is going to be 6, or you can measure it from the midline to the bottom part, which is also going to be 6, or there's also a formula way you can do it. You can go the highest spot minus the lowest spot, so just like we did the midline, except it'd be a subtraction instead of adding, and then divide by 2. So in this case, 8 minus -4, so that'd give us plus 12 divided by 2, which is 6. So either way, like I said, use the diagram, use common sense, or use the formula, whichever. And the last one, the period, that one, remember, is our horizontal distance. So a few different ways you can do this one. You can measure from peak to peak if you know the coordinates. So in this case, it's hard to see, but I tried to have the first point at 1.5, and the second one was at 6. So you could just go 6 minus 1.5, and that would give us 4.5 radians for the period. And just like before, you can go whichever you want. So here it might be easier. We're going from 0 to 4.5, so that would be a distance of 4.5. Or we could use any other coordinates. You could go from here maybe, so that's at about 0.5, and over here you can see it's at should be at around 5, so then the difference there would be also 4.5. So if the graph is drawn right, and you'll see the questions on the worksheets are drawn pretty good, you can easily count the squares to figure out the period that way. The other part of the graph that you have to be able to do is domain and range. So domain, remember, is all our x coordinates. So in this case, our graph started at, when x was 0, we had y of -4, that was our starting point. And then you can see on the other end of the graph, in this case, it goes on and on forever. So if the graph went on and on forever in both cases, we'd have xer like we did with other equations this year. But in this case, that's not right because we're not going to the negatives. So we would have, in this case, just x is greater than or equal to 0. Okay? And if it stopped on the other end, instead of going on and on forever in the positive direction, let's suppose it went from 0 up to 10, then you'd write it as between 0 and 10. And that's how, when we're doing range, it's always going to be like that. So in this case, our range is going to go in our y direction. We have a minimum of -4, a maximum of 8. So that means our range has to be between -4 and 8. So we write it as -4 less than y, which is less than 8. And every question like this, when you do these, the range will always be between your max and your minimum values. Domain could change depending on whether the ends continue on forever or not. Okay, so just a quick review of all of this stuff. So when you have your sine graph, doesn't matter how big it is or how close or wide or skinny or narrow, just basically look at the graph and you want to go through that process. So you want to determine where the midline is. So where would that line be to cut it right in half? So that'll be your midline. Then you want to figure out where your amplitude is, so that'll be your distance from midline to your peak, or midline down, whichever way you want to go. And then remember, your period is from where the graph does one complete cycle. So peak to peak, or any other two parts of the graph, that's the same. So all three of those will be important numbers that you need to be able to figure out from the graph, or vice versa. They could give you a question where they give you those numbers and then you have to figure out the graph. So let's do one of those. Okay, so let's go through this example. So let's suppose we have a graph situation where we know it's a sine graph. They're going to tell us our y-intercept is 2, so that's sort of like our starting point. Our domain is going to go from 0 to 10, so we know it's starting at 0, going up to 10. And we know our range is going from 0 up to 4. So we know our graph is going to be in that area. We just have to figure out what it's going to look like. So let's start with the y-intercept. We know the y-intercept is going to be at 2, so we're starting there. Okay, and we know that the graph has to go between 0 and 4 in the y direction, so we know it's going to go up and down. We just don't know, is there going to be one big sine graph like that, or would it be a whole bunch of small ones close together? That's the trick you need to figure out, and that's where the period's going to come into place. Remember, the period tells you how often it repeats, so that'll tell you how big it's going to be. So let's start at 2. And we know, because they tell us a period of 4, so we know that after 4 squares, it's going to be right back to where we started. So to do one complete cycle, and we know it's got to go up, so we know that it's going to go up and back down to where it started halfway through. So halfway would be at 2, and then we also know that it's going to go up and down. So let's just sort of put all that information together so we know our graph should look like that. So there's our sine graph for one complete cycle with a period of 4. It's from 0 to 4 in the range. That's good, but it's got to continue up to 10. So we can just continue that pattern until we get to 10. So there's 2 complete cycles, and then we'd have a half or a little bit more of the next one, and that's it. Actually, I screwed that one up. Let's erase that and start again a bit. So it's going to go up to there. It's going to go up 1 and then back down. Okay, so you can see from, if we have a period of 4 and we had a range of 10, so 4 would be one cycle, 8 would be the next, and then 2 more would give us a half more of a period on the graph. So you can see that we're going just like that. And that's it. So when you're doing these kind of graphs, just sort of put all that information together and sketch out your graphs. So the worksheet that we're going to look at is titled 8.3, the graphs of sinusoidal functions. So we should be able to complete all of that worksheet. The questions are going to ask things of what's the amplitude, what's the range, what's the period, what's the midline, and other ones will be sketch the graphs and make them look kind of like we just did. So I'll stop there. I'll attach the 8.3 worksheet and you guys can give that a try. Tomorrow what we're going to do is do some regression on real life situations, figure out the regression equation and tie that into how does that relate to our midline, amplitude, and period as well.